Okay, you can actually take this and highlight it. For those of you that are open-minded to trying Excel, okay? Those of you that don't want to use Excel, then you keep doing what you're doing, okay? Those of you that maybe want to try some Excel, that's fine. 51, there is 51. So you highlight them, and then you go up to data, and you dangle A to Z right there. There. They're in order. Okay, let me make this a little bit bigger for y'all because I know it's not, I can't see what y'all see, so I'm going to make it a little bit bigger. And let's go with center. And let's go with 16. Okay, so there's your points. Now, let me go back to the question. And here is the point. So what I'll do, well, I can't do that. Go ahead and write down these classes, 100 to 199.9, 200 to 299.9, 300 to 399.9. Go ahead and write those out in your notebook or your piece of notebook paper so you'll have them. And we're going to go through and do this frequency distribution. Okay? It's pretty easy to do. You just do it up to 1,300. 100, 200, 300, 400, 500, 600, up to 1,300. And then you do 199, 299. Class width is what? 100. Good. So you're the one that listened. Okay. 100. 200 minus 100 is 100. So the class width is 100. If I wanted to find the midpoint, I could find the midpoint. I'd add them up and I'd then multiply, add 100 on each level. If I wanted to find the class boundaries, it's to the 10th. So I'm going to go to the 100th. So 99.95, 199.95, 199.95, 299.95, 299.95, 399.95. That's the class boundaries. Okay, now let me go over to my handy dandy spreadsheet, and the first one is 100 to 199, right? So 100 to 199, I'm going to color them yellow. And what's the next one? 200 to 299. Color them dang old 300 to 399. Dang old, whatever color that is. 400 to 499. And so on. 500 to 599. 600 to 699. Running out of dang old colors. 700 to 799. And the last one is that one. Okay? So I'm just going to do this. 100, 200, 300, 400, 500, 600, horse pookie. 400, 600, 700, 800, 900, 1,000, 1,100, 1,200, 1,300. I'm not going to put the upper class limits. Y'all can fill that in. I'm not going to do that. Okay, 100. So we go to the 100s. We got how many? 4. 200s. 200s we got, let's go over here and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we go back over to 200 and put 16. Next one, 300. Go over here. It's easier when you can see it all on one screen, but I made everything bigger so everybody could see it. I do so much for y'all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. So you go over to the 300s and you put 9. 400s. 400s, you go over here and count. 1, 2, 3, 4, 5, 6, 7, 8. 8. 500. 500 is 5. 600 is what? 1, 2, 3, 4, 5, 6, 7. 5 and 7 and 1. 5, 7, and 1. So 5, 7, and 1, and then 1300 is what? Okay, now this is a concept y'all need to think about. If there's nothing there, you put what? Oops. There we go. All right, so now let's check to see how many we got. That's supposed to be 4 right there. I don't know. Oh, I don't know what I did. Okay, now let's add them all up. Make sure we got 51 because that's going to be our end. Dang old 51. So, if I want my relative frequency, I'm going to take this number and I'm going to divide by what? 51. I'm going to hit F4 to lock it because I'm going to copy it down. And here we go. And there's your relative frequencies. And that's how you do a relative frequency and a frequency distribution. Okay? That's it. Now, the reason I showed you this question was to show you the feature of copy and pasting over into the spreadsheet. That's why I did it. Okay? All right. And that's what they're going to ask you. But there's the button right there. Now, I copy into Excel, and you can do what you want to, but that's what I do. Okay. Now then, let's go over another question. I want to go over, let's just look at the homework and let me pull up some questions that I want to do, because that way we can copy and paste it over. Let me get out of this. So let me get out of that. Let me go here. Okay. Try that again. There we go. And homework and 3 point, I have no idea which one it is, but I think it's around 3.3 or 3.4, so I'll just pick on 3.4. And let me see what I can pull up. And pass all the daggum vocabulary. I'm going to do those. Let's see. Nope, that looks like empirical rule. Yep, that's empirical rule. We'll get back to that. Just give me a second. Be okay. Let's see, get out of this. Homework. 3 point, what I just picked, was that 3.4? 3.2. Should be 3.2 then. Okay, compute. Okay, just forget the directions. We're going to do everything. Okay, so here's your 4 numbers. So go ahead and we're going to copy and paste those into Excel, so I ain't got to write them. And there they are. And now I want each of you to go ahead and start doing everything. Mean, median, mode, range, mid-range, variance, and standard deviation. Meanwhile, I'm going to blow everything up. So we're going to blow that up to here, and blow this to here, and center, and 16. And I'll insert a couple of rows. There we go. And n is equal to 4. And I'll just go over here to the far right, and I'll put in mean, median, mode, range, mid-range, variance, and standard deviation. I'm going to give y'all, let's see, it's 12:47, so 3 minutes, give y'all about 8 minutes to work on that. If you can't do it in 8 minutes, then you need to consider yourself pretty much failed in life. My daughter says she knows you. She said all kind of bad things. I saw your West Side shirt yesterday. I kind of figured when she said she went to school with somebody in one of my classes, I kind of figured it was you. Oh, that's good. College of Charleston. She's going to history. And she needs to make something worthwhile. So she made history. Actually, I love history, but I asked her if she was going to teach real history or if she was going to teach doctorate history. She didn't know what I was talking about until she took her first history course. She figured out what I was talking about. They didn't teach us that in high school. And I said, well, I said, politically correct history. She was also going to live in Charleston the rest of her life, too. And I said, yeah, that road's going to get long.
Yeah.
Oh, I'm going to live in Charleston forever. 1 year. Here she comes back. Yeah, but it's kind of like when you go to the beach. After about 2-3 days, you're ready to come back home. Well, I think after about 3 months, she was ready to come back home. How you coming, Easley?
We're fabulous.
You ain't quit yet?
I'm from Easley.
I need to make the questions harder then.
No.
Yeah, because I need to get y'all discouraged to quit. That's what I'm supposed to do as a math teacher, right?
Whatever you do, I ain't quitting.
Yeah, you will. You won't fail.
I ain't quitting.
Yeah, you are. You're young. You'll see.
Well, I can't quit. I'm old and I'm supposed to graduate in August.
No. Oh, that's even worse.
Oh.
Now you're going to get a double letdown. You're going to fail this course and you're not going to graduate.
Oh, no, that's going to be sad.
And then you'll probably lose your job and then end up in a ditch. See, everything works out. That's what I told my daughter. She got her an internship at the museum. I said, you're going to fail. Thanks, Daddy. You're welcome.
The Father of the Year award.
Huh?
Father of the Year award.
The lowest. Minus.
Oh, well, I gave up being Father of the Year after I got divorced. I knew I wasn't going to get Father of the Year. All right. Equals. Let's go with the mean. Let's go with the summation. I think I gave y'all enough time. I might not have, but let's go with divided by 4. So everybody should have got 377.
Yes.
Good job. The median. Uh-oh. Well, let's take this guy and change, magenta. Let's use magenta. And cover these two like that. And that's going to be equal to, parentheses, this guy. I didn't put them in order. Hot dog it. Hold on a second. Thank you, sir. There we go. Thank you. Okay, I think that's all. Okay. I'm sorry. Parentheses. I'm a failure. It's still not in order. What the? It's the Russians. It's the Russians. The Russians, it's their fault. Whenever something doesn't go right, you blame somebody else. How's that? Is that better? Okay, so let me fix these colors before some of y'all go insane with y'all's OCD.
That would be me.
Okay. Well, I'm OCD. I have to have everything centered. So I'm weird too. It's medication. Those 5 or 6 pills I take every day. It's kind of getting kind of old after a while. All right, there we go. Where'd my magenta go? It went away. There we go. We'll make it a little bit lighter. All right, equals, parentheses, 408 plus 420 divided by 2. And y'all's median should be 414. Now, somebody tell me right at the get-go what's going on. Why are these two not together? Ugh, that's not right. Why are these two not together? Somebody tell me. Articulate volume. All I heard was
It's outlier.
Huh?
Outlier.
Not outliers, but what? Well, you could say an outlier, but look at the numbers. Somebody tell me why we have a problem already.
They're not tight. They're not tight.
They're not tight. Why? Tell me what number is not tight.
228.
The 228. As she said, there's an outlier. There's something screwing up the data. And that's what it is. So we're talking about sumo wrestlers. The average weight of sumo wrestlers, we're talking about, notice I said wrestlers. The 228 is a misnomer because, not misnomer, an outlier because sumo wrestlers are supposed to be like gigantic, huge beings, okay? So the 408, the 420, and the 452, they're in line, but the 228 is not. So we change that to 428 or change it to 400, you're going to start seeing the mean and the median start to line up. Okay, so anyway, just wanted to see if y'all remembered what I talked about the other day, which I was amazed that y'all remembered. Equals non-applicable here. So I'm going to put nairn. Now you might not want to use nairn because somebody might, mark it wrong because they don't know how to speak Southern. But N-A because there ain't nairn. Okay? Range is equal to the highest minus the lowest. Mid-range. Now what do you do with the mid-range? Average them up. The highest plus the lowest divided by 2. Okay, now we got to start with the formula. So the formula says x minus x bar. So we're going to call this x. And this column right here is going to be called x minus x bar. And I'm going to take the 228 and I'm going to minus the mean and hit F4 for those Excel people. And I need you to check your numbers in that column. And what does the formula say after we get x minus x bar? What are we supposed to do? Square it. Dang, did y'all take notes? Gosh, I'm not used to this. Equals raised to the second power. And copy down. Okay, so we've got x minus x bar. We've got x minus x bar quantity squared. Now what do we do? That funky looking E, what do we do? Add them all up. And that is your numerator for your variance. So I'm going to take my variance and I'm going to put my numerator on top. Divide by parentheses 4 minus what? And there is my variance. Variance is not really worth anything because unless you go into Math 220, which we quit teaching that because people couldn't hack it. Standard deviation is the square root. So that's equal to this raised to the 1/2 power. Now I want y'all to draw the bell curve and I want you to put the mean in the middle and I want you to go 3 standard deviations to the right and 3 standard deviations to the left. And I want to draw it because we're going to put the empirical rule in and we're going to fill in the empirical rule with the bell curve so everybody will, and we're going to do that with every question from here on out. So that way, hopefully by the test, you won't say you haven't never heard of the empirical rule. That's what it should look like. Now make sure you know the empirical rule. The empirical rule says that 34%, 13.5%, 13.5%, 2.2%, or 2.3%, and 0.2%. 2.3% and 0.2%. And somebody tell me again, page 137, is that it?
132.
I'm sorry, what?
132.
132 is the empirical rule. Okay? Now, I'm going to take my green highlighter, which you should take your green highlighter if you have one, and you're going to highlight this area green. Now, if you have a book, turn to 133 or 132 and tell me by the empirical rule, or by adding up in your head, what's the percentage of the group that's going to fall between two standard deviations? %. So, I need you to put in here, 95% will fall in what we call normal. My daughter used to say normal, but she also used to say theater. So, normal, within two standard deviations. Now, look at, what do you mean two standard deviations, Hubert? Well, this is 0 at the mean, meaning that's the center. And then just think of your number line. What's to the right of 0? 1. What's to the right of 1? 2. What's to the right of 2? 3. So 478 represents one standard deviation from the mean. 579, two standard deviations from the mean. What about on the left? Same thing. -1, -2, -3. So 95% of the population usually is going to fall between two standard deviations. In this case, between 175 and between 580. All right, let's take yellow and let's highlight this area right here. And that area is between the second and third standard deviation, and that is called unusual. And then we'll take a pink color. Let's go with magenta. And highlight this area. And highlight this area. And that is the 300-pound second graders. Okay? That's your what? Outliers. Okay? That's what's way out of the norm. Okay? Now, you also need to be able to read from left to right. And I tell students to think of the bell curve as your dang old indicator on your fuel. Okay? You read over here, what's full left on your indicator of your fuel indicator? What is it? E, right? Well, this is 0%. And what is this right here? A quarter of a tank. Well, a quarter is 25 what? %. So right in here, well, you take those two and add them up. It's right in here, really. So this is about a quarter right in here somewhere. And then when you get to half a tank is what? 50%. So 50% is right here. Okay? And then this is 3/4 of a tank, which is 0.75. And 0.75 would be somewhere in here because this is 81%. So 0.75 would be right in here, 75%. And then, of course, what's this side over here? This is 100 because it's full. Okay, this side right here is full. You always read it from left to right, and you always read it like a guessing. Okay, that's the easiest way to explain how to do the empirical rule. Capiche? Make sure you know how to fill that out, because that will be 3.3 or whatever that section I went into a while ago and I had to get out of it, 3.4. That is on the empirical rule. Okay? And there'll be some questions. We'll do some of those questions also, not today, but probably when y'all come back. Okay? Tuesday. Yeah, Tuesday. Now, let's look at the numbers. And we can see that these numbers are way out of wampus. Okay? For those of you that don't know what way out of wampus is, wash a bunch of dadgum towels and see if your washer don't get out of wampus. Out of balance. Okay? It's out of balance. So take your handy dandy highlighter and go down here and do the mid-range and color it yellow. And of course, look at those numbers, and you can say they're out of wampus. But if I change this to 400, like I did a while ago, you'll see them start to line up. Okay? You need to write this down. Everything in statistics is based on center. Not center like Bible center. Center with a T. Okay? C-E-N-T-E-R. Everything is based on the center. When you look at statistics, when you look at probability, when you look at calculating statistics, presenting statistics, or being shown as a presenter showing you information about your work or your career or whatever, your major or whatever the case may be, everything is based on this guy here. The center, everything. So if I change this to an outlier of 4, you see those 3 yellow numbers, they just go all over the place. But if I change it to 407, they start to line up. Okay? All right, so let's go over to the next problem, and I'll pick one out of the homework. So therefore you can have 2 problems that I made up and 2 problems out of the homework, so you can't moan and complain. Some of you will anyway, but I'm going to learn that. Let's put a bunch of numbers on here so y'all can moan and complain. Oh yeah, there we go. Now I will not give you a question like this on the test, okay? But you need to learn how to do it, and I would highly suggest that you do this on the Excel spreadsheet, because the more decimals you have, the more chances you're going to have to mess up. So I would highly suggest doing that on an Excel spreadsheet, or do it however you want to, but I wouldn't give you that on a test. The problem I just did, I would. Okay, let me see. Okay, that's not anymore. 3.2. Okay, what's that? That's comparing. Okay, we can do that. Open in Excel. Now here, they're going to ask you to compare. Now, they go through every letter of the alphabet on some of these questions. I can't stand those type of questions. But what I'm going to do is I'm going to take this guy, and I'm going to hit Control X. I'm going to come down here, and I'm going to put him right here. Now, I'm going to compare these 2 sets of data. This one, first thing I'm going to do is put it in order. I'll blow it up in a minute where y'all can see it. I'm sorry. I'm being self-centered. I'm sorry. I don't know what's gotten into me. Let's go with 14 and centered. Okay, so go ahead and write that first set down. and I'll move down and set up the second set. All right, I'm going to move down and put these in order. I'm going to go ahead and take some of these out. Maybe I can get all of them on one. There we go. Well, almost. There. Now, I want you to find the mean, median, and mode, and all that good stuff, all the way down to standard deviation for both of these. Both of these sets of data. And that'll be pretty much five examples for your notebooks, because this is 2 sets. So that'll be 5 sets of data that y'all have done. Now, in this question, they're going to ask you to compare, and like I say, they're going to use every letter in the alphabet, just about A through Z, as parts of the questions. But what I tell students to do is go ahead and just do the math, and then therefore all you can do after that is just look on your paper and type in the answer. Don't try to do what they tell you to do, because they're going to have you going around the world. Just go ahead and find that list of questions, mean, median, mode, range, mid-range, variance, and standard deviation. Then once you do that for both sets, then go back to the question and answer the questions. Ryan, you should be close to finishing up. And if you aren't, just keep working. But if you'll look up there, I have some things highlighted. And from those things, you can automatically see Group A is a better set of data than Group B. What's the two things that tell me that Group A is better than Group B? That's not rhetorical. I'm asking y'all to give me some input.
The numbers are tight.
How can you tell? What's the two things that tell you that the numbers are tighter in A than B? I'm sorry, what? The three numbers in green are closer together than the set B. If you'll look, you'll see that there's a little bit of a difference. The mean and median and mid-range have a closer proximity than the bottom. But even if you just ignore those three, what else do you have? The standard deviation. The lower the standard deviation, the better. Okay? That means that your data is not spread out as much. So if you had two standard deviations on a test question, and they say which one is better, you would go with the lower one. So the standard deviation and the three numbers tell you that Group A is your better set of data. Okay? And that's what you should be able to do. You should be able to calculate all these things, and then at the end you should look at it and say, okay, this is the better set of data. Now, those questions, the A through Z questions that they're going to ask you, they're going to ask you to write, they're going to, what is the mean of the first set? What is the mean of the second set? What is the median of the second set? What is the mean? They're going to go back and forth. So that's why it's easier for you to actually have all of the computations done before you actually answer the question. Okay? All right. So that's 3.2. Okay? 3.3, we're talking more about the empirical rule. Now, the good thing about the empirical rule in 3.3 is you don't have to do a whole lot of calculating. Okay? Let me show you what I'm talking about. Well, with 3.3, you got to do a lot of drawing, and you got to know the empirical rule. So if you don't learn the empirical rule, you're pretty much going to suck at 3.3. All right, so homework, 3.3. 3.4, sorry. And I'm just going to pick a problem. Okay. Now, let me go ahead and tell you this, and you're going to learn this in the coming weeks. Whenever you see mean and standard deviation, that is a 25-cent flag, red flag, for draw a curve. Okay? So, if you don't like to draw, then you need to go get you a piece of printer paper and go to copy and paste and go to the internet. I'll show you how to do this. It's a lot of work. Okay, you have to hit at least 3 or 4 buttons. Okay, you go to the internet. I don't care where you go. I don't care which engine. And just look up. I don't forget what it's called. Curve. Normal. Curve with empirical rule. And you hit images. See, that's 2 buttons you had to hit. And you had to type in those words. You know, a lot of work, but you know, it's worth it. Now, take your pick. I don't care. I usually use the one that's down here. Watch me not be able to find it. This one's good because it's got everything down at the bottom. There's another one I use, and I don't see it. Of course, any other time I'd see it, but I don't see it right now. Don't want a lot of stuff. You don't want it too busy. I'm trying to find it, but just like everything else, it never happens when it's supposed to. It's the Russians. All right, then go use that one. Let's go use this one up here. So, where is it? There, that one. Hey there. All right, so here's the one that I told you to use. Now, as you see, this 2.35 is different. So you can ignore that, or you can, I don't really care, okay? Take your book and mark through that and put 2.3 and mark that and put 2. I don't care, but you need to fix it. Then copy this. You can copy it, save picture as, and save it as normal graph. Okay. Now, if you don't like this one, if you don't like it because of the, I don't like it because of this down here. All right. So I'm not going to use it because that would be too confusing. So here's another good one, but that one's good, but the only problem is it's got all this stuff up here, and that's good for the empirical rule, but I don't want that. So any other time I would find mine. This is a good one. All right, so I'm going to save this one. This says 1 standard deviation, 2 standard deviations, 3 standard. That's what that says. So I'm going to go to my, you can save it as a file. I'm just going to go through and hit the snipping tool, and I'm just going to cut it out. But you would save it as a file and then bring it in on your word processor and put 6 of them to a page. I'll show you that too because I'm used to showing it. So I'll go ahead and let's see. I'm going to save this as a. You got to hit 3 buttons now. So that's 3 buttons. Maybe a 4th button to put it under pictures. But I'm telling you how much work is involved here. Word. And you make it into 2 columns, if it'll let me in. Okay, layout. Somebody tell me where the columns are. They are 2 columns. And then you can insert picture. We're up to 5 buttons now. There it is. And you can copy it and go down here, hit enter. Go down, enter, Control V, Control V, Control V. You can get 4 to a page, maybe 5. I don't think you're gonna get 5. Maybe. Yeah. You're over. Okay. And just keep hitting it. Okay. We're up to what? 7 buttons now. So I don't know. Some of y'all may not be able to handle all this work. Okay. Is that 8? And then print this off. And then run 50 copies of it. Okay? Or print this off 10 times. And that'll be daggum 80 curves that you have that you don't have to draw because you're going to get sick of drawing these curves. Especially when we get to Chapter 7 because you have to draw them because you got to see what you're actually looking for. So this is just a hint that I give people. If I have a class of 30 people, 1 or 2 people will do this. And the others will bitch about having to draw it. Okay? So, you learn that, you pull it in, and here we go. So I'm going to pull this in. I can't pull it in. I'm going to have to pull it in as I don't think I can pull it in as transparency. Nope, I cannot. But I'm going to have to draw it. Okay, I don't feel like copying this, so I'm just going to draw it. I can't bring it in on the transparency because I have to be on the whiteboard to do it, and I don't feel like doing all that, so I'm just going to draw it. All right, I know that I've got this and this, so I automatically know I got to draw a curve. The bigger you draw it, the better, so it's more stuff you can put on it. Okay, the mean is 100. 156, 152, and 178. Somebody check my math because I suck at it. 100 minus 26 is what? 74? 74 minus 26 is 48. I don't know what it is. What is it? I'm sorry, what? 74 minus 26. 48. And 48 minus 26 is 22. Okay, so this is 1 standard deviation, 2 standard deviation, 3. 1 standard deviation, 2 standard deviation. Now, you just knocked out half of this question. Okay? Because out of all the questions that I give you on the Unit 1 test, besides discrete and concrete, this is the most missed question. Because students, they do everything they can to make it difficult. All right? What is the minimum score that an applicant must make? So I got to read the first part. A highly selected boarding school will only admit students who place at least 2 standard deviations above the what? Mean. That's discriminatory. All right. So 2 above the mean. Y'all read about that school that everybody gets to be a cheerleader? Everybody gets to go to the school. Everybody. That's being discriminatory. Okay? So everybody gets a trophy. So 2 standard deviations. So what score is 2 standard deviations above the mean? 152. So all the boarding school students have to score above what? 150. And that is the answer to the question. The minimum score that an applicant must make on the test to be accepted is 152. Now you see, that question is not hard. But what happens is some of y'all, meaning students in general, not y'all in here, some of y'all students, y'all start what? Thinking.
Overthinking. Yeah.
Yeah. And when you start thinking, that's when you get in trouble. It's not you overthink. That's a good word. Overthink is a good word. Because you start, okay, well, what about the mean and the median and the mode and all this? And I'm like, I ain't said anything about the mean, median, and mode. We stopped that after the last question. All right, this is something different. This is the empirical rule, page 132. All right? Now, they're not going to ask you for a percentage on this question, but they may. So let's see what happens. Golly, I know what I'm doing. Next question. I'm confident. All right, let's go to the next question. I want to get one that has the actual... Well, we can do that. This will discourage you. All right. A manufacturer of bolts has a quality control policy that requires it to destroy any bolts that are more than 4 standard deviations from the mean. Okay, so when you see that 4 standard deviations from the mean, you know it's going to be an empirical rule question. Mean of 8 with a standard deviation of 0.1. So that means you need to draw a picture. So draw a picture, everybody. Draw a curve. Now you're going to have to make it bigger because you got to go 4 standard deviations instead of 3. You need to make it about half the page. It needs to be a big one. They're not that difficult. Come on.
Look,
now that looks good. It looks like it's wrong, but that's okay.
4 standard deviations from the mean. Is that what he's saying?
what is the standard deviation?
What's the problem, Aisley? Y'all talking too much. What's the problem?
Can't read that tiny writing.
Okay, let me draw it for you. I'll just go ahead and draw it. So, the mean is 8. Now, you might need a calculator for this because y'all don't know how to add money, right? It's not important for you to be able to add money. I worked at Walmart before I went to the Marine Corps. I worked in Walmart, 396 up here. And I would watch people. I love to watch people. And one day I was sitting in the lounge up front, watching the cashiers, because I worked in sporting goods, of course. And I would watch the people when they got their change back. Okay? And the guys, you could give them $20 less change, and they wouldn't know. They just walk off. Thank you. Put it in their pocket, and they just walk off. Women, a nanosecond, they would figure it in their head. Okay? You shortchanged me 5 cents. Boom, just like that. All right? But when I ask you to do this in math, you reach for a calculator. Think about it. What's $8 plus 10 cents? $8.10, so that'd be 810. Okay? You got to think about stuff like that, all right? Because the biggest question I get in math, I will ask somebody, what is 6 times 25? And they'll reach for the what? Calculator. But if I ask you what 6 quarters are, you tell me it's $1.50. You don't even reach for a calculator. 6 times 25 is 150. 6 quarters is $1.50. And you would be surprised on how many students never make that connection. All right? Make that connection. Don't sit there and go, okay, 8 plus 0.1. Reach for the calculator. It's $8.10. 8. I'm sorry. And what's $8.10 plus 10 cents? 8.2, 8.3, and 8.4. Okay, now the other. What's $8 minus 10 cents? 7.9. 7 point what? 8. 7.7. Now I know that's elementary, but you would be surprised when that's a 0.25. Oh my gosh, people reach for the calculator. But you ask them what $8 plus 2 quarters is, and they'll say, oh, it's $8.50. But when I ask you to add 8 and 0.25 and 0.25, somebody reaches for the calculator. I don't know. Maybe y'all can figure it out. Maybe you can write a book and become famous. Okay? Because I can't. A manufacturer of bolts has a quality control policy that requires it to destroy any bolts that are more, have I done 4? 1, 2, 3, 4. Okay? Less than 7.7 and more than what? 8.4, Hubert. Thank you, class, for the interaction. All right? So, blah, 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 blah. For what lengths will this bolt be destroyed? Less than what? 7.7 centimeters and more than what?
8.4.
Yeah, wherever that is. Is that B? You pick B and you fill in the answers. And I'm telling you, this is the second most missed question on the Chapter 1 test, on the Unit 1 test. If I could get the mouse to work. Well, my mouse disappeared. Just give me a second. Y'all know it's them Russians. And about 50 other excuses. 7.7 and 8.4. Oh, this is Zscores. I didn't know this was Zscores. Okay. All right. I'm sorry. I didn't know we had jumped into Zscores. All right. Forget it. Forget it. That's the right answer when it comes to empirical rule. All right. We're not going into Zscores yet. Say again.
There's 3 standard deviations on the left side.
Oh, there's only 3. 1, 2, 3. Up. Thank you.
One more.
Thank you. That's so it's supposed to be 7.6. I'm sorry, I only went 3 on the left. I suck. 7.6. So, but this question is not a empirical rule question. This is a Z-score question, but we're going to treat it as a Z-score question. 7.6, I'm in a empirical rule question because I'm not getting into Z-scores yet. So the answer is 7.6 and 8.4. Okay? I don't want to get into Z-scores yet. Now I want to find the premature birth question. Because that's the question that's on the test and everybody misses it. Even when I put it in your notebook, y'all still miss it. So look for the premature birth question. Just give me a second to find it. It's not supposed to be. I thought this was... Okay, well, I'm just going to make it up. All right, the question is going to ask, let me go to the whiteboard. The question is going to ask, it's going to say, the standard deviation for premature birth is 15 days. I remember 15 days, I think that's the actual question. Okay? And that's all they give you. And then they say, what is the probability? What is the probability of a baby being born within 30 days of the due date? Within 30 days of the due date. D-A-T-E. Okay? Now, it doesn't matter what the numbers are. The first thing you do is you draw a curve. And I don't care how many standard deviations, at least 2. Okay? Now, I want to ask, okay, guys, I'm going to be a little bit discriminatory here. Women, if you have a baby on the due date, is that more days or less days than the due date? Think about it. More or less than the due date? It's not either. It's not neither, is it? You have it on the due date, right? So the mean is going to be what? 0. Because 0 means that you had it on what? The due date. If you had it 1 day after the due date, then it'd be 1 to the right. If you had it 1 day less than the due date, it would be 1 to the left. So the due date, and that's what it says, what is the probability? 30 days within the due date. And I think the question actually says due date. I can't remember. But that right there tells you that the mean is equal to what? X bar is equal to what? 0. And I'm just going to put X bar is equal to 0. Because that means that you had the baby on the day that you were supposed to have it. Now, I have to explain that, but some of y'all understand it. Especially if you had a baby, you might understand it. All right. So, this is 15 days within. This is 15 days what? Early, right? A minus would be 15 days early. Over would be 15 days over, meaning overdue. This is one of those times when I tell you that people don't fail probability because of the math. The math is very what? Elementary. The problem, and let me tell you, there are people out there that can't freaking read. All right? Oh my gosh. The last day, yesterday, I had to drink last night. I'm sorry, I had to. I got 3 emails last night, or yesterday afternoon, from my online class. You know what they said? What is the attendance quiz? Because I sent them a whole week. You got to take the attendance quiz the first week, and the attendance quiz asks like, when is the last day of class? You know, what is, and it's a thing that says that you attended the first week of class. And I get these 3 emails. I got 40 students. 40 in my 2 online classes. 40 students. I get 2 emails saying, I'm confused. 2 out of 40. They're not reading the handouts. Okay? They're not reading. And then people read them, and then they like, well, what's the attendance? They read, what's the attendance? They don't even, okay? That happens in this class. This class. Now, what information are we extracting from this question? We're pulling out that 0 is the due date. That's the mean, because that means it's not over. And then, if we're overdue, that means it's 15 past. If we're under, that would be negative 15. And you're having to think about this stuff, and it has nothing to do with the calculations or the math that you have to do. You have to read and extract this information from the question. And that's why people miss this question, because they don't extract. They don't say, okay, well, if I have it on the due date, then that means that's going to be 0, because that's the due date. Think about it. All right, so if I add another 15 days onto this overdue date, what's it going to be? Dang old 1 month overdue. And then what's this one going to be? 45. And then what's this one going to be down here? Negative 30 and what?
Negative 45.
There you go. Now I want you to go back. I want you, everybody right here, to put in the empirical rule percentages right now. That's the only thing that you're going to need is just the percentages. Put those in. If you don't know them yet, you're disappointed. Okay, here they are. 34, 34, 13.5, 13.5, 2.3, and 0.2. And 2.3 and 0.2. Okay, so what have we done? Let's see. We have justified this, so that's gone. We justified due date. What is the probability of having a baby 30 days within the due date? So what is that?
97%.
Not 97.
95.
Nope. Not reading the question. Are you not thinking? Come on. Somebody knows it, but they're scared to say it because somebody's already said 95 and 97 and got it wrong. Come on. Boy, y'all really suck. You know that? No, I'm just kidding. Come on, spit it out. 30 days.
47.5.
Nope.
Is it magically 99 cents?
Nope. Just leave. You're such a disappointment. Just leave.
27%.
Nope. I'll take one more guess. As soon as I say it, you're going to go, oh yeah, 68%. Somebody tell me why.
I saw it was right before you said it.
Why?
30 days within the due date.
Yep.
Oh my God.
See? Some of you starting to see it.
Yeah. Okay.
You see it?
God.
What's 15 plus 15? No. 30. Some of y'all still haven't seen it, some of you don't care. But I understand you don't care. But some of you are going, well, I don't understand 30. I said 30. No, 30 would be 30 and 30, which would be what? 60 days. So here is a question to where, one, you have to extract three things. You have to extract that mu is equal to 0, or x bar is equal to 0, because that is the what? Due date. All right? And then you have to, there was another thing, I can't remember what else there is, but there's one other thing. Well, you have to also know the empirical rule. And then once you do those two things, then you have to think 15 plus 15 is equal to 30. So this area right here is within 30 days. Okay? Now, I may not have the question written exactly like it's supposed to be, and some of you can say, well, no, that's not the way. Just take my word for it. When you see this question on the homework or on the test, you'll know what to do. Okay? Because I made you aware of what you have to extract from this problem. Okay? And if I can find it, it may be in the 103 class. I can't remember. I can't remember which class it's in, but it's either in the 120 or the 103, because that's what we teach probability in, or statistics. Anyway, to make a long story short, just remember those two things. Due date would be 0, and the standard deviation within 30 days. Here's 0 days, and here's 30 days. Or you can go, here's 0 days, and here's 30 days. This is 30 days right here. And you have to, some people say it's a trick question, but if you think about it, it's really not a trick question. Because 60 days would be 30 and 30. And I think that's one of the reasons that one is the most missed question, especially to those students who can't read their handouts. All right, so that's another good question. You'll see that one again. And let's go back to the, I don't want to do the Z-score, so I thought these were, I thought Z-scores were last. I'm sorry, I thought this was empirical rule. Let me see if I can find another empirical rule question. Because the empirical rule questions are the ones that get y'all messed up. 5th percentile, no, that's Z-score. That's Z-score. That's Z-score. Is that all? No, that's not. Yes. Okay, we did that one, did we not? We did that one. Here we go. This is one like it. At least I'm thinking it is. It may be a Z-score one, but it can
I think that one's a Z-score too.
It is? Okay, yeah, it says it right there. Thank you. Well, I must be just way off. We must have to go to 3.2. It must be in 3.2 where they have them. I can't remember. But make sure you know the empirical rule. Okay. Well, we got time. We got a little bit of time. I don't want to go into Z-scores yet. But let me go ahead and go into Z. I'll go ahead and introduce you to Z-scores. Let me go to the whiteboard. And Z-scores. Let me pull up a question that I always give students. Just give me a second and I'll pull it up. I hadn't planned on going into Z-scores today, but... Okay, LBJ versus Shaq. Z-score. Really? PDF. Gosh, really? Just give me a second. Let's see. Oh yeah, people don't know. President Johnson Oh, forget it. Usually I can pull it up and it comes right up. It's the Russians hacking into our system. Let me just draw it out. Let me just write it out. LBJ was, I'm just going to make these up, I'll tell you what, somebody Google LBJ and then height. And then somebody Google Shaq's height. Shaq is, somebody do that for me. What's LBJ's height? I think he was 72 inches. Does that sound right? I'm sorry, what?
6'8".
LBJ was 6'8"?
LeBron? Yeah.
Not LBJ is President Lyndon Baines Johnson.
When you say
He's
Shaq,
6
and you say
Okay, well, I'm sorry. Yeah, you would think that. But what they're doing is they're comparing a president to a basketball player, and I'm going to tell you why in just a minute. So, I'm sorry. Lyndon Baines Johnson, how tall was he?
6'4".
He was what?
6'4".
Okay, what is 6'4" in inches? 60 would be, so that's 60 what?
So it's 70.
64 inches? Yeah,
No.
64 inches? I don't know.
No.
76 inches, okay, 76 inches. Well, the presidential mean of 72 inches and a standard deviation, I know I'm going to get this wrong, of 3.3 inches. Okay? Somebody tell me the height of Shaq in inches. 70. How tall was he?
85 inches.
Is he what?
85 inches.
85. So that's what? I don't even know
No, it's
that.
85 inches. 85 inches.
85 inches. Thank you.
He's 71.
85 inches. And the probability of basketball players at that time, I have no earthly idea of what it is. I want to say it's 81 inches. No, that's not right. What is 6'6"? 6'6" would be 72 plus 6, 70, 78 inches. 78 inches with a standard deviation of, I'm going to say 2.1. I may have those bass acronyms, but oh well. Now, what do they ask? They ask who is relatively taller. Okay? Now, any redneck with two teeth in their head will tell you that Shaq is taller than LBJ. All right? Shaq is taller than about 90% of the population. Okay? So that's not what the question's asking. Relatively taller. For instance, what is the qualifications for being president of the United States? I didn't hear anything. Articulate. Volume. What is the qualifications for being president of the United States?
You have to be a
Have to be a
citizen.
citizen, a natural born citizen, and what else?
Have to be
You can't have a
35.
felony. You can't have felons, a list of felons. You can't have that. You have to be at a certain age. What? It's 35 or 36 or something. I don't know. You have to be a certain age. Okay. What is the height requirements for being president of the United States? There isn't. Okay? If you think about it, there was one guy, somebody look it up, the shortest president, I think it was 5'5" or 5'4". Somebody look it up. How tall was the shortest president? 5'5", McKinley? Madison. Was it James Madison? How tall was he?
5'4".
5'4". Okay? I don't know how many of y'all are 5'4", but 5'4" is not tall. Okay? All right. Well, what does that have to do? Somebody, which one was in a wheelchair? Nope. Which president was in a wheelchair?
Roosevelt.
Roosevelt. How tall was he? Well, you don't count him tall being in a wheelchair or count him tall standing. You would count him tall standing. But he was less than 5'4", if you think about it, in a wheelchair. The whole point is there is no qualification. Okay? Even though in the last election, Jeb Bush stood on his tippy toes in photographs so he could be president. Idiot. Anyway, they called him, he was standing on his tippy toes. Whenever they would take a picture of all the presidential candidates, he would stand on his tiptoes. They They actually took pictures of him standing on his tiptoes. Anyway, that's real pathetic. Who is relatively taller? So LBJ would be a big fish in a what? Little pond. Think about that. Big fish in a little pond. Why would he be a big fish in a little pond? Because there is no requirement for height for a president. Right? So if he's tall, he's a big fish in a little pond. Whereas Shaq, let me ask you a question. If you're in the 6th grade and you're 6'2", who's going to be knocking on your door when you get to junior high school? Say again? High school
Coaches.
basketball coach. Why? You may be dumb as a rock and can't dribble basketball, but why is he coming to you wanting to play basketball? Because you're tall. So, Shaq is a little fish. Now, I know little and Shaq don't go together, but he is a little fish in what? A big pond, because what are one of the requirements for being a good basketball player? You got to be tall. Okay? Now, Spud Webb was the different argument. Okay? He was 5'5" and he could dunk. All right? But 99.9% of your basketball players have a what? A height advantage. Okay? So, relatively. What does relative mean? Some people can say, well, in physics it means you put your, you go to a movie and the movie lasts for 2.5 hours. If it's terrible, it feels like it's 3 days. Or if you go to a movie and it's a real good movie, it feels like it's over in 30 minutes. That's relative. All right? Same thing with this. What is relative? Is President Johnson taller than Shaq in their prospective populations? Who's taller? So when you have a question like this and you're comparing apples to what? To oranges, you have to put them both on the same score, which is called a Z-score. Z is equal to X minus X bar over the standard deviation, or S. Sorry, used the wrong. I mixed the parameters. I'm such a bad math teacher. So I want you both to figure the Z-score for LBJ and the Z-score for Shaq. Z-score for Shaq, or LBJ, is equal to 76 minus 72 over 3.3. And what is it?
1.212.
I'm sorry.
1.212.
1.2. I've got this bastard. Z of Shaq is equal to 85 minus 78 over 2.1. What does it come out to be?
3.3.
Yeah, I got it wrong, but it's still different questions, different numbers. Same question, different numbers. All right, so which one is relatively taller? Well, the correct answer is LBJ, but since I made it up because I couldn't find the question, I got the numbers wrong. But in other words, LBJ comes out to be like 1.6, and Shaq comes out to be 1.5. Okay? The further you are from 0, the more ER you are. That's the way I tell students. Shorter, taller, whatever the question's asking. So, if this question was asking which one's relatively taller, you would say Shaq, because on a scale, on a Z-scale, just like the curve, 0, 1, 2, 3, -1, -2, -3. This is a Z-score normal curve. LBJ is right here. 1.2, right in there. And Shaq is 3.3. So he's further out, so he is more unusual. So he is relatively taller. Okay. Now let me read. The answer is LBJ, but I've made up those numbers. But if you see this question, the answer is LBJ. I just messed up on the. I think I had the standard deviation switched. I can't remember. All right. So that's what you do when you're trying to find who is relatively, and then you say ER, relatively shorter, relatively heavier, relatively bigger, relatively whatever. Okay? Now, also, if you're comparing two test scores with two different class averages, I think there's a question on your homework, economics versus a psychology test. All right? Same concept. All right? Same thing. You're going to change it into a Z-score. There's one other formula I want you to write down here, and that is X is equal to Oz plus mu. Now, the reason I write it as Oz plus mu is because if I put it in the sample parameters, it wouldn't make any sense. Okay? The reason I put it in the population parameters is the sigma looks like an O, and the Z, that Oz, you can remember Oz, and then mu is mu, so Oz plus mu. If I put it in the other one, it would be SZ plus X bar, and you can't remember that. I can remember Oz plus mu, but XZ plus bar, or whatever, it's just SX bar, or X bar Z plus S, or plus X, or whatever. It's just, see, I can't even remember. Oz plus mu is a whole lot easier to memorize, all right? And that's when you're trying to find the height, and we'll get into that when y'all come back because I don't want to get into that yet. I think this is enough for now for you to chew on because I don't want to get into this yet. Okay? So when you are comparing apples to oranges, that's what's going to happen. You're going to change it into a Z-score. Who was the heaviest president? Or the biggest? Who? Almost Taft. Taft was the biggest president. He was a pretty big old boy.
He got stuck in the bathtub.
Yeah, he got stuck several places. I mean, he was a pretty big boy. All right, y'all can put your stuff up. I'm going to go ahead and conclude class today. I got to call the roll so I can turn in attendance so then people can send y'all emails if you're not here. Give them a job. Justify their job like any bureaucrat. I have no use for bureaucrats. If you can't teach, then just do something else. Administrative. Okay. Vestido.
Here.
Fry.
Here.
Okay, all y'all are there. 5. Okay, easily y'all can go have a good weekend. I'll see y'all when? Wednesday, Tuesday, somewhere in there.
Tuesday.
Yep. All right, Bolding. Brown.
Here.
Y'all can leave after I call your name. Burdett's here. Elias is
Hi,
here.
y'all.
Garrett
Hi,
is here. Grant is here. Lowry is not here. Marion not here. Moss is here. Pegues is here. Pickens is here. And Rhodes. Rhodes is not here. All right, y'all have a good day and a good weekend.
I got a question real quick.
Mm-hmm.
Okay, so is that sigma? Sigma, is that what you said? That little O looking
Yeah,
thing?
Oz.
What does that stand for? Is that,
That's we'll get this the 2.1 and the 3.3. You would plug that in, but we hadn't done it yet. Huh?
Is that standard
deviation, yeah, for the population. But it doesn't matter. I'll show you how to do that when we get to them.
And the SX?
That's the standard deviation.
Standard deviation.
Mhm.
Okay, that's what I thought.
Yep, that's the same thing as the sigma.
Just wanted to double check with that.
Yep.
I have a quick question.
Oh, I'm sorry. Go right ahead. Yes, ma'am.
Okay, on the variance
I don't know how you're getting it. Like, I understand the x bar squared and then add them all up, but what are you doing after that?
Divide by n minus 1.
Divide by n minus 1?
Yes. The formula is right here. Variance is equal to the summation of x minus x bar quantity squared over n minus 1. So in that first problem we did, n was 4, so we divide by 3. 4 minus 1 is 3. In the second one, I think it was 8. The second with the 2 parts. 8 minus 1 is 7, so we divide by 7.
Got it. Okay.
It's always n minus 1. Okay?
Yep, thank you. Appreciate it.
Yes, ma'am. Have a good weekend.
You also.
Long weekend.
I know it.
I kind of like those long weekends.
Me too.
Y'all be careful. Bye-bye.